Okay, here I've got a couple of examples. Now, thinking back to our last video, we can use some of the concepts there about reference angles to find the exact value of, having a look here, we've got, in our first example, a non-acute angle, right? And so we can use our reference angles, our idea of reference angles, to find out the sine of that particular angle. Now, we can go straight to the rule, but I think it's a really valuable exercise to go ahead and draw this out. So I'm going to go ahead and draw a unit circle and put our Cartesian plane over the top. And then if we think about where that angle would be, right, 225, it's going to be 180 plus an extra 45 degrees. So it's going to be roughly there. So let's go ahead and draw the angle out. There it is there. And so our angle, the size of our angle is this. Right, let's zoom in a little bit. That's our angle, and we'll call that 225 degrees. Now we know in the third quadrant to find out, right, to find out what our reference angle is, it's a simple matter of finding out what this angle is and taking away from 180, and that'll give us this leftover part here. Okay, so let's go ahead and write it down. We know that the sine of our 225 degrees is equal to, and because we've gone down in our third quadrant, right, the sine, how far we had to go down, the reference angle is going to be negative. So it's the negative sine of our reference angle. Now, to find our reference angle, it's theta minus the 180 degrees. All right, let's do that. It's the angle minus 180, and it will give us this little part here, the reference angle that we're interested in. And that's what we've done here. Now our angle is 225, so we can replace that with 225 because we know what it is. And now we can establish that the sine of 225 degrees is also the same as the negative sine of 225 minus 180, that is 45 degrees. Okay. Now, we've got our trusty little table for sine of 45 degrees, and it's just a matter of making our answer negative. So I do believe we've still got our table ready to go. No, that's not there. So let's go ahead and find our table. There it is here from other works. I'll go ahead and copy it. Copy. Let's go to our original page and let's paste it in. I'll just make it a little bit smaller. And so if we look at it, we can identify, right, the sine of 45 degrees is 1 on root 2. So the sine of 225 degrees is equal to negative 1 on root 2. Okay. As you can see, drawing the unit circle helped us identify, what it really did is it helped us identify what quadrant we were in. But if you know 225 is in quadrant 3, you don't have to draw the unit circle out, but it just helps me identify what quadrant we're in, because each particular quadrant has a slightly different rule to work out the reference angle. So remember, in the third quadrant, it's theta minus 180, okay? Let's now go ahead and do question B. So I'm going to go ahead and just resize this, and we'll move this up to the top here. All right, the cosine of 11 pi on 6. Now, that's a bit of a strange fraction there, 11 pi on 6, right? 11 on 6. But if you put 11 on 6 in the calculator, or if you think about it, 11 on 6, 11 divided by 6, it's slightly less than 2, right? Because if it was 12 divided by 6, that would be 12. So a little bit less than 11, 11 divided by 6, it's not going to be quite 2, it's a little bit less. And we know that if it was 2 pi would give us, well, that would be a full revolution. So it's going to be slightly less than a full revolution, and I predict it'll be slightly less, and that means it'll be in our our fourth quadrant, right? I'm just thinking out loud, but let's go ahead and just do it. So again, my strategy for this one will be to draw the unit circle. Okay, so there's a couple of different things that we could do. I could take this approach in a couple of different ways. What we could do is just do 11 times pi, which we know is 180. So 11 times 180 divided by 6. And that'll give me the angle that we're interested in. But if we don't have a calculator and we just want to work in pi, well, we can estimate this, right? I know, and I'm going to do some work below, that 11 pi on 6 would be equal to, and I'm going to write an equivalent fraction here, would be equal to 12 pi on 6, take away the extra pi that I just gave it, right? So just 1 pi on 6. Let's think about this. 11 pi on 6, 11 of them, right? 11 pi's divided by 6 would just be equal to 12 pi's, take away that 1 extra pi, right? I've just written them as equivalent fractions. Now, what is 12 pi on 6? Well, if we think about what 12 divided by 6 is, that's 2 pi, right? So I'm going to write this again. So 11 pi on 6 is equal to 2 pi's, take away that 1 extra pi, okay? Divided by 6. So what is 2 pi? We should know by now that 2 pi is a full revolution, right? Starting here, pi on 2, pi, 3 pi on 2, 2 pi. 2 pi is a full revolution. Can you see that in doing this, I've noticed that 12 pi on 6 is a full revolution. Now, when we go around a full revolution, we end up at the exact same point. So think about what I'm doing here. I've basically expressed 11 pi on 6 as a full revolution and then take away this extra pi on 6 right there. I'm just averaging. I'm just roughly estimating, right? Now, I know pi on 6 is 180 divided by 6, which is 30. So I'm going like this. 2 pi, take away 30 degrees, or pi on 6. So I'm going to roughly be here. And I'm going to estimate that. Here we go. I'll draw an angle. Let's use our straight edge. Roughly there. And then, going around, that there, that whole angle, let's zoom in. It's 11 pi on 6. Now, if we know that's 11 pi on 6, right, our reference angle will be the full circle, because we're in the fourth quadrant here, and we established the rule in the fourth quadrant. Let's write this in black. In the fourth quadrant, right, to find the reference angle, which will be this part here, right, the difference, or the angle between the x-axis and the terminal line, it's equal to 360 degrees minus your angle. But in this case, we're working in terms of pi. We're not really working in degrees here, aren't we? So I can re-express this as not 360 degrees, but 2 pi. Take away our angle here, which we know, right? Our angle here is 11 pi on 6. 11 pi on 6, okay? And so what's remaining here, I hope you can conceptualize this without having to do the math. If this is 11 pi on 6, well, to get that little reference, it's just that extra 1 pi on 6, right? So 11 pi plus 1 pi on 6 will give us 12 pi on 6, which is 2 pi, okay? So our reference angle here is 1 pi on 6, or just pi on 6, right? And we know that's 30 degrees, but we're gonna stay in pi form. So let's go back to our question. So we know that the cosine of 11 pi on 6 is equal to, now because we're in the fourth quadrant, cosine is still positive here. That'll be equal to the cosine of our reference angle, which we just determined was just 1 pi on 6. And so because we know what the cosine of pi on 6 is, because we've got our table here, the cosine of pi on 6 is root 3 on 2. So the cosine of 11 pi on 6 is root 3 on 2.